Good morning, everyone. My name is Lina Isabela Ospina and today I will present the article Color Transparency and Line from Holographic QCD by Gerald A. Miller, published in 2022. First, let's understand what color transparency is. It is a phenomenon where a particle, like a proton, can pass through a nucleus with very little interactions. Normally, the particle loses energy very quickly inside the nucleus. However, in color transparency, it behaves almost as if it were invisible. The article describes this as a form of quantum invisibility. For this phenomenon to occur, three conditions must be satisfied. First, high-energy reactions must produce very small and compact groups of quarks, called point-like configurations or PLC. Second, these small configurations interact very weakly with other particles. Finally, although they tend to expand at very high energy, they do not have enough time to grow. To study this, Miller used the FMS criterions. He introduced simple expressions to measure the effective size of the systems. If this quantity decreases as energy increases, then small configurations are formed. But if it increases, this indicates that such configurations do not exist. Next, the article analyzes gauge functions from line from holographic QCD. This is a theoretical framework used to describe the internal instructions of hadrons. It combines line from dynamics with an holographic approach based on anti-de Sider space. Miller used this gauge function to test whether small configurations appear. Miller studied two types of models. The first is a simple model for the pion. The second is a more completed model that includes 2, 3, or 4 quarks. In both cases, he evaluates the same quantities to see how it behaves as energy increases. This is the key result of the paper. If we look at figure 6, we can say that for models with 3 and 4 quarks, the value of B squared increases with energy. This means that the system does not become smaller at high energy. As a result, the model does not produce point-like configurations. In conclusions, the wave functions of light from holographic QCD do not generate small configurations of course. Therefore, they do not predict color transparency. This result is consistent with experimental observations, where the effect has not been clearly seen at these energy scales. Thank you for your attention.